SwayamPrabha. Digital India. Educated India.
Welcome to the NPTEL online certification course on structural systems in architecture. The week 5 is on truss and the space frame. So, we are in the second lecture on this truss and the space frame, and this will be on the analysis of truss, and that is the part 1. So, in lecture number 23 we will discuss the part 2 of the analysis. So, in this particular lecture we will first going to discuss about the indeterminacy of the truss, and then we will analyze the truss. We will see the two typical types of analysis method of the truss. One is called the joint method and one is the section method of the truss analysis, and we will do try to understand this by some examples. So, the course objective of this particular lecture will be, we will outline the various method of truss analysis. Definitely that is the prime goal of this particular lecture, and we will do the analysis of the truss by virtue of both the methods, very popular method, the joint method and the section method. First of all, let us see what is the indeterminacy. Indeterminacy we have already discussed in the very first week of lecture. If you have some clarification, you can go back to the first week lecture, I think lecture number 3 or 4, and we can actually get clarified. The indeterminacy is the redundancy, that is the unknown forces. How many unknown forces are there in a particular system, that is you have to first judge, and then we have to actually find out that whether it is possible to tackle find out the unknown forces by virtue of the three statically equilibrium equations like sigma fx equal to 0, sigma fy equal to 0 and the sigma m equal to 0 or not. If it is then it is determinate, and if it is not, it is indeterminate structure. So, truss will have two type of indeterminacy. The first one is called the external indeterminacy, and the second one is called the internal indeterminacy. So, what is external indeterminacy or the determinacy, whatever you may tell, is that in case of the external indeterminacy of the truss is depend upon the support conditions and how it is actually how many supports and what type of supports are there in the particular truss, because supports are you may say it is the external the body or external the system which is plugged into a particular system. If there is a beam has 2 supports or 3 supports, whatever. So, those are the beam is if you say this is a beam, it has some 1, 2, 3 or maybe 1 support. So, those are the plug-in systems. So, you have to see that how is those systems are there, support systems are there into that particular truss systems also, and the applicability of the indeterminacy will be same as it is in beam. So, suppose this is a particular truss. I have shown a truss of a with so many members and so many joints. Joints are put in the yellow dots and members are black straight line, and I have actually rest that particular truss in a or on a one simply support, hinge support and one roller support. And as we know that this roller support will give you a unknown force like this, and this will give you a force. So, let me first erase it. So, this will give you a reaction force in this plane and this plane, and this will give only one reaction. Those three the support reactions are unknown, and those support reactions are external. You see, external. First I have to see that whether it is externally stable or unstable or indeterminate or determinate. So, there are number of unknowns are 3, and we have 3 equations available. So, this is externally determinate structure also. So, with the help of the statical the equation of the stability equations or the equilibrium equations, we can easily solve this particular 3 unknowns. But if it is something like this, there are 2 supports, one both are hinge. So, this will give you a reactions like this, and this may give you reactions like this. So, there are 4 unknowns, 4 unknown reactions, because of I have changed one roller to, and I put another support over here, and the horizontal to vertical support or something like that. So, but I have only 3 equations are available. So, I cannot solve this particular, because 4 unknowns cannot be solved by 3 equations. So, compatibility equations are required. So, that cannot be handled so easily. So, it is not a determinate kind of a structure, it is indeterminate kind of a structure of degree 1. Because why degree 1? This is because the unknowns are the unknown minus the equations are you can say this is the degree of indeterminacy. So, this is 4 minus 3, which is equal to 1 is the degree of indeterminacy. So, we need one compatibility equation to solve this particular problem. So, it is externally indeterminate kind of a structure. So, now let us discuss the what is the internal indeterminacy. A structure or maybe a truss can be externally determinate or maybe indeterminate, whatever it is may be. So, that will actually allow to take some type of method to find out its reaction. If it is externally indeterminate, I will choose some strain energy method or some other method to find out the reaction of those 4 reactions or so. Or if it is statically determinate kind of a structure, so very easily I can find out the reactions by virtue of those 3 equations. But after that we have to see the internal members, how it is actually geometrically linked with each and other, so that I can easily compute those internal forces by virtue of those 2 or the 3 equations of the statics or so. So, the rule is, if you go with this kind of a triangulations, see the joint, how many joints are there? There are 3 joints. These yellow dots are joint, and the members are in this is the joint and this is the member. Members are in your the link, that is the black color straight line. So, we have 3 member, 3 joint. So, this equation is holds good, m equal to 2j plus minus 3, because 2j is how much? 2 into 3 minus 3, which is equal to again 3, 6 minus 3 equal to 3. So, this equation holds good. So, next what I will do, I introduced another joint. So, one joint is added. So, that joint is now 4 instead of, so this is 3 plus 1, but for one joint I have to connect 1 plus 1, 2 members. So, the members is now 3 plus 2, 5. Still this is okay, because 2 into joint is now 4 minus 3 equal to 8 minus 3 equal to your 5, right. So, still this m equal to 2j minus 3 is holds good. Let us go one step further. So, we have added another joint. So, now joint is your 4 plus 1 is your 5, and 2 members are added. So, 5 plus 2 equal to 7. This equation still, or this relation, not equation, it is a relation, still holds good, because it is your 5 into 3 equal to your 2j minus 3 equal to 2j, sorry, this is wrong, let me erase it. This is 2j. So, 2 into 5 minus 3. So, this is 10 minus 3, which is equal to your 7. So, this relation is holds good. So, here what happened is that if you have 3 such member, and out of that 3 member, these 2 member are connected at this particular joint. Of course, this joint have 3 member connection, but at least there are 2 member connected in 2 such points. We can easily find out the forces because of these 2 static equilibrium equations, sigma fx equal to 0 and the sigma fy equal to 0. So, if you proceed like this, so after we solve this particular joint, so this member force and this member force is known to me, then this particular next joint can be found out by, because these two are unknown and then this is already known. So, we can find out this like that. We can also, if I know this 3, then I can find out easily this 2, because I also know this one. So, this 2 will be unknown to me. So, gradually you see, if you start from a joint which is having 2 unknown or a joint having 2 member, from there if I start, I can easily gradually go to the next joint and next joint like that, and finally find out all the forces by virtue of the sigma f x equal to 0 and sigma f y equal to 0 equation. So, that means if this kind of the scenario is holds, this kind of relation is holds between the member and the joint, this truss is intermediately or its determinate, internally determinate. So, we can say that the truss is internally statically determinate if this relation holds, this m equal to 2j minus 3. If the truss is having more than 2j minus 3 member, then you have a problem. Then somewhere in the internally we have to stop. You cannot actually find out those forces by virtue of those equation. We have to now think of some compatibility kind of scenarios also. So, what I have written over here, you see, this is a 4 member 4 joints and 4 to 4. So, this here what happened, the joint is 4 and member is also 4. So, this particular equation gives me 2j minus 3 equal to 4 into 2 minus 3, which is equal to 5, but m equal to 4. So, this is m is less than j. So, that is very unstable. You see, I have told in the last lecture that 4 pinned with 4 link is very unstable, because if you place it something like that, it will going to unstable, it will show instability. So, if the m is less than j minus 3, 2j minus 3, this relation if holds in a particular truss system is statically unstable. Whereas, if you see this, next we have introduced a third member, fifth member. So, then the joint remain 4 and member remain 5. So, this equation or the relation holds now. Then I can say this is the statically determinate kind of a scenario. And so, I can say this is a statically determinate and stable kind of a scenario, and this is a statically stable and internally determinate kind of a structure. I can easily start from this point and I can find out the loads or the forces in the member. But if I go in this, I have joint, another more joint and another one member, introduce another 1, 2, 3 members. Now, I have 7 members and I have 5 joint. So, this is going to be m equal to 7. So, m equal to 7. So, this is also fine. So, if it is, this is also fine to have that particular kind of equilibrium equations help me to find out the load. But if I have this kind of a pattern where joint is 5 and the number of member is 8 now, total number of member is 8, then 2j minus 3 is 7, but members are 8. So, now the relation is m is greater than 2j minus 3. So, the truss is statically unstable, statically stable, but internally indeterminate. So, I cannot actually find out all the 8 member forces by virtue of this sigma f x equal to 0, sigma f y equal to 0 equation. I have to search for some one extra equation, because the degree of indeterminacy here is m minus 2j minus 3, which is equal to 1. So, 1 degree of indeterminacy. So, I required one such equation to me. So, in the joint method of the truss, what we will do? We will assume each and every joint typically, and we have to go one by one. We have to draw the free body diagram of each and joint of the each nodes, and we will apply this particular the simple equation sigma f x equal to 0 and sigma f y equal to 0. In this analysis approach, the two joint have maximum 2 unknown forces has to be tackled. So, we have to go like that. And in case of the section method, it will be typically we will do break the truss into 2 typical parts, and we have to draw the free body diagram. See, free body diagram of the left or right side of the truss, but what happened to here is that we have to free body diagram of each joint, right. So, it is only either left side or the right side of the truss, and we will apply the equation of sigma m equal to 0, the moment equal to 0, and we will try to find out the what is the unknown forces also. So, we will discuss with some example. So, suppose this is a kind of a truss which is a parallel cut truss. This is having a supported at the L1 and L5, the supports are here L1 and L5, and these are the 10 kilonewton load. So, I can easily find out the support reaction as 25 because it is symmetrical and there are total 50 kilonewton load. So, it is divided into the half, and this is 2 meter and this is 1.5 meter of the depth. So, let us go with the joint method. So, I have to first touch this particular L1 because this having only 2 members associated with this particular joint L1. So, I can easily find out these 2 forces. As and when I can find out these 2 forces, I can jump into this node, because then this is already known to me. So, these 2 are unknown, and then I will jump to this because already this is known to me. So, and this is also known to me. So, this I can find out, these 2 are unknown. Then I will join back to U2, that upper one. So, upper ones are nomenclated as the U1, U2, U3, U5, and lower nodes are it is written as L1, L2, L3, L4 and L5. So, we will go to the U2, and U2 I can find out these 2 unknowns because those 2 unknowns are already known to me, and finally, we can come back to the U3, and then I can find out the what is the force over here, and it is symmetrical. So, I can just replace the values in that way. So, now if I go, I first find out the angle theta is this angle theta. So, sine of this angle and the cos of this angle has been found out by virtue of this relation 1.5 meter and 2.5 meter, and if you take this particular joint, putting the sigma fx equal to 0 and the sigma f will be equal to 0. So, I will get this is as a compression and this is 0. Now, why this is compression is that because in the free body this particular joint is under compression. So, joint is under if the force is towards the joint, that means joint will be under compression. So, we will write is as a compression because in the force diagram it look like a tension. So, you do not have to confuse in that way. So, I have already put this is 25 and this is 0 by virtue of the first joint analysis of L1. In the second, I have to take U1, and in the U1 this is I know this is equal to my 25, and I have to put this is this force like that. So, the opposite and equal force like that, the upward way, and this upward way has to be transmitted to here. So, these 2 are the unknown forces, these 2 are the unknown forces. I can solve with the sigma fx equal to 0 and the sigma fy equal to 0, and finally, I can find out this is 25 and this is 20 and this is 25. This U1 L1 is this one. See, this one is I have written tensile because the force what I have assumed is also correct, and this is giving the tensile force to the joint. It is actually trying to take out the joint from that particular. So, it is tensile, whereas U1 U2, that means this one, this the top chord is the, you see the rotation is, I have choose the rotation like this, which is correct also, which is I am not getting a positive answer. So, it is correct direction, and this gives the compression to this particular joint. So, in the free body, so that is why this is compression. So, I can now write these 2 unknown forces as this as I think this as 25 tension and this as 20 compression, and as it is compression the direction will be like this, as it is tension the direction will be like this, and let us see it is like this. Okay, it is like this. So, now let us I can go to the L2 L1 sorry L2 this force, because these are these 2 are unknown to me, and I can again find out those forces you can go through and then find out, because this angle is virtual, this angle is theta. So, you have to use cos and sin theta, what we already you have found out, and we can find out the loads also. And then L2, so we have to go to now U2 is this, and these two forces are unknown. So, we can find out this two forces like that, and finally, we can compute the forces and the whole result is V2. And you see this is very symmetrical. So, if you say this is 25 compression, this has to be also 25 compression, because it is symmetrical. Symmetrical trusses, we can solve the half portion of the truss and you can rewrite the things over here. So, this is 0 force member, this is also 0 force member. Like that, this is suppose 8.33 tension. So, the opposite to that mirror image 8.33 tension will be there. So, like that it is whole the trusses can be solved by virtue of solving the half portion. Now, section method of the truss can be think, or we can apply this section method. So, here what I have written, the same truss I have taken, I have solved already. So, I can actually match the answer by the section method also, but here I have to find out the forces in U2 U3, U2 L3 and L2 L3. So, what are those? These three members I have to find out only. I do not have to find out the other members, only these three members I have to find out. So, I will create a section over here. So, I will bifurcate the truss into two portions, and either I will take the left or the right portion and try to solve the truss by virtue of the moment. So, I have to take this the left portion. So, I have erased this portion, the right portion, and I have zoom it out and this portion. So, you see I have this U2 is visible to me, U1, U2 is visible, and L1 and L2 is visible, L1 and L2. And there are three cutting forces or the cutting members which I have written F1, F2 and F3. First of all, I assume that all are tensile forces, so it is coming out from the joint. So, I have to check the balance of the left portion, and I have to find out the F1, F2, F3, what should be the correct values of F1, F2, F3, and what should be the correct direction of the F1, F2, F3, so that this total half system, the left part of the system come under equilibrium, no rotations, nothing. So, for that I have to use some moment equations in each joint. So, I have to take the moment either in this point or any point, any 4 of this point, or maybe any point here also. Maybe if I extend this to force, and I can use the moment at this particular point also sometimes, but I cannot take in between the members. So, I have to only take those nodal points to find out the moment. So, first I take the moment about U1. So, moment about U1 gives me a fundamentally it will be I have chosen U1. Why? Because if I take U1, then automatically the moment created by F1 and F2 will be 0, because F1 and F2 passes through U1. So, this distance is equal to 0 from U1. So, the moment created by the force F1 and F2 at U1 is equal to 0. So, if I now take, so this F3 is having a distance 1.5 meter. So, the F3 into 1.5 meter. So, this goes like this, must be equal to 25 into this much of distance, right. Why this much of distance? Because this 25 load is having a separation, perpendicular separation of this distance, that is 2 meter, which is opposite directional moment, and this 10 into 2 is counter directional. So, this is minus 2, 10 into 2, that gives me F3 equal to 20, and this direction is right. So, it is tensile direction. Next, what I have to do is that I got the value of the F2 is the F3 as 20. So, I still have to find out the F1 and F2. So, I have taken the moment about U1. Why U1? Now, this force F1 passes through U1, same line. So, this will be automatically 0. So, 1.2 into F2, 1.2. So, from this point, the perpendicular of this, I have found out this distance is 1.2 meter from the trigonometry. okay, from the this your cos theta and all. So, this is F2. So, this gives you a moment like this, and this 10 into 2, 10 into this 2 meter, perpendicular distance is 2 meter, is this must be equal to this 25, and this 10 is vanish because of this particular the linearity, collinearity. So, this 20 into this F3 into 1.5 meter, because F3 or 20 is has a separation distance of 1.5 meter. So, that goes the other direction. So, this way, so I can find out that F2 equal to 8.33. So, F3 equal to 8.33. And finally, I have to take a moment from L2. L2 is here, and if I take L2, already I found out this, so then now it will be very easy to find out this F1. So, the moment of F1 from this point is F1 into 1.5 meter. So, this F2. So, this is the line of action of the load. So, this distance again it is 1.2 meters. So, this is 1.2 meter into F2, but F2 already I know, that is 8.33, and then your 25 into 2, because this force will doesn't have any moment. So, this 25 into 2 is this, which is counterbalancing, and this 10 into 2 is this, equal to this. So, we have equate, and then finally, we can find out that the F1 is equal to 26.67 compression. So, this is the value of the F1, and you can check with the values with the section method value, with the joint method value, and these three values are valid. So, like that section method has been taken into consideration, and where we have to take the each and every point and try to locate the point such a way that one forces is can be found out from the by nullifying the other forces. So, that is why I have taken the U1 as the first joint, the U2 as the second joint, and the L2 in the first third joint, and gradually I found out one after another the forces or so. So, another joint method examples, truss examples have the same span with the same height, but it is a one kind of a truss. So, you can solve this, and you can go through the PPT for the solutions and all. So, it has also will have the forces like this, I mean the reaction forces like 25 and 25. Again, if I can find out the half portion of the this thing, so I will start from here. So, and first find out the what is your sin alpha and cos alpha. So, this angle I assume as the alpha. So, you know this is your 1.5 meter, and this is your 1 meter, and then this is your 1.8 meter, this hypotenuse, and you can find out these values of the cos and the sin alpha. And from this particular L1, if I first take, you can find out these two forces, and then you can go to the L2 sorry U1 the upper chord first point. So, then you can find out these two, because then we can you go into U2? We cannot go to the U2, because this force is known to you, but these three are unknown. So, three unknowns in a particular joint will be typical. I mean, you cannot find out, you at least require two unknown. So, then we have to go to this L2, because in here this is known to you, this is also known to you. So, you can find out this. So, you can go back to the L2. Now, probably you can go to the U2, because then this also known to you. So, these two are unknown. So, like that, and finally, we can solve the other part, because it is symmetry. So, if I take the first joint, if you see the look into the first joint, these two forces are having a force of 25, and I assume that these are the direction of the forces. So, you use the Fx equal to 0 and sigma Fy equal to 0 equation, you can find out the forces. You can find out the forces for the next joint U1 also, because this force is now this L1 U1, the L1 U1 is now is 30 is known to you. These two are the unknowns, and you can find out these two values, and then go back to the so these values are now known to you, and then you go to the joint L2. So, these two values are known to you now. So, you can find out these two values. So, gradually you can go, and then finally you can go to the U2, and you can solve this by sigma f x equal to 0, sigma f y equal to 0, and this half portion of the loads or the forces in this truss is solved, and you can repeat that to the other end also. It is very symmetrical. You see, this is 30 and this is also 30, this is 24.75, this is 24.75, like that. So, this with the PPT will be provided with this particular lecture. You can go through, you can try to solve this. If you have any problem, please write to the forum, we will answer you. If you each and every joint has been taken into account as a the sigma f x equal to 0 and sigma f y equal to 0, and that manner, and we have found out the forces. So, we have taken the reference of this particular books for this particular chapter, for this particular PPT or particular discussions. So, let us conclude this particular the discussions, like the structurally the stress is consist of the external and the internal indeterminacy. That is the first thing we have to look into. First things we have to see that how it can be solved by either the equation of statics or not. The determinate stresses are analyzed by the joint method and the section method. The indeterminate stresses are solved by some other method of the indeterminacy method of some typical strain energy method or so. So, those are not in the scope of our the discussion. So, that is all in the lecture number 22. In the next lecture, we will continue this analysis of truss, that is the part 2 of analysis of the truss in lecture number 23. So, I have given you some homework. So, this is a truss, very simple truss. So, there are members, you have to find out the member load by the joint method. So, this is a 2 meter and by 1.5 meter rise 2 meter the span truss having the weights of 5, 5 and 20. It is also very symmetrical. So, if you can find out the loads or forces at least in this 4 member, you can rewrite in this 4 member also. Okay. So, and another one, so the same truss which has been solved in this particular problem. So, you adopt, I have actually I have solved this by the joint method. So, here you have to find out the forces in this 3 first and this 3. So, this 3 is this one and this 3 is this section by section method. These 3 members are by the section method. I think that is all for this lecture. Thank you very much.